All right, good afternoon, everyone. And another year has gone by, and we are honored to have the next recipient of the Russell L. DeSouza Award give a talk about their contributions to the Unidata community using many of Unidata tools and resources. And I just wanted to give you a little bit of a background on this particular award and how it came about. And we are always, honored to recognize the individuals who have been given this award over the years. Russ DeSouza was one of the most prominent Unidata community members when Unidata was getting started. In fact, he and I started on the Unidata Users Committee the same day back in 1989. And he came to Unidata Committee as a member of the faculty at Millersville University of Pennsylvania. And Russ was such an energetic community member, so enthusiastic. He actually, going back to the discussion we had about workforce development earlier this afternoon, got his students involved in picking a sector, where the GOES observations or imagery would be gathered and distributed by Unidata through the McIDIS data stream. And each day his students had to pick the area of interest, and that was a great educational experience. And they would essentially send us the centroid or coordinates of that location, and we would, Tom and company at Unidata would, have that data distributed to the community. Russ went on to greater things. After a few years on the Unidata Users Committee, he joined the Policy Committee and enriched the conversations on the Policy Committee, was deeply involved in the development of proposals, steering the program forward. But unfortunately, around 1995 or so, he developed cancer and passed away after a year or two. But his impact on the program and the community was immense, and Unidata established this award to recognize those members in the Unidata community who make outstanding contributions. I'm just going to read you the terms of reference for the award. The Russell L. DeSouza Award honors individuals whose energy, expertise, and active involvement enable the Unidata program to better serve geoscience. Honorees personify Unidata's ideal of a community that shares data, software, and ideas through computing and networking technologies. Russ DeSouza clearly personified those ideals that became the terms of reference for this award. And we gave the very first award in 2000 to Harry Edmond from University of Washington, and over the years we have given this award almost every day with the exception of I believe 1 year. And I'm delighted that Kevin Tyle, who personifies these ideals to a T, is being recognized this year for his human contributions to not just the Unidata Program Center, but also our entire community through his efforts and activities, not the least of which is his contributions to the deliberations of both the Unidata Users Committee, which he chaired admirably for 3 years, and now as a member of the Strategic Advisory Committee. I'm going to ask, as is the tradition, the chair of the Users Committee to read the citation and say a few words about this award, and Kevin Tyle.
Okay, so I'll come over over here too to use the mic so we get recorded. So yes, it's a great honor to introduce this year's Russell DeSouza Award winner, Kevin Tyle from the University at Albany. It's been a great pleasure to work with Kevin over the last several years on a variety of projects. One, as he was as Mohan mentioned, he was the chair of the Users Committee around the time I started on the Users Committee, and then became followed in his footsteps to chair the committee. And then we've also gotten to work closely along with some other folks in the room here on the Big Weather Web proposal and project, and through all of these activities, certainly I've learned how much contribution he makes to our community that we see sort of in these meetings and beyond in the much larger atmospheric science community. Just always being there to help and you know, leading us in new directions in our field and so forth. So I do want to read. There's a bit of text here, but I do want to read it because it's some good work that the others put together. I added maybe a little bit to this text, but it's a great citation. So the Russell L. DeSouza Award for Outstanding Service to the Unidata Community. This acknowledges Kevin Tyle, University at Albany, State University of New York, for your dedication, enthusiasm, and inspiration that truly reflect the goals and ideals of the Unidata program. We present Kevin Tyle with the 2017 Russell L. DeSouza Award. You exemplify these ideals through your readiness to embrace new techniques and your willingness to spend countless hours helping others understand and use them. The digital data challenges in the geoscience community often seem insurmountable, but your inclusive approach makes the hurdles less daunting, and your positive attitude electrifies any group you're a part of. And while there may be extended discussion threads, THREDDS, among reasonable people as to the nature of a good pun, we appreciate your attempts to lighten the mood on cloudy days. We offer this award in recognition and appreciation of your many years of outstanding service to the Unidata community. GP end.
Thank you so much. Thanks, Russ.
I guess we'll get a picture with that.
Thank you. Great honor. Got a lot of folks to thank and acknowledge, but that will wait for a little bit later. So let's just, hopefully we have a nice GP start as I open this up again. That's not really a GEMPAK command, but maybe it should be. Okay. So, once again, great to be here. Never thought 10 or so years ago I'd be leading a talk like this, but let's see how things go. So, my talk is on visualization. So, a little bit of a background. I think these talks oftentimes delve into some history, both personal and then in the field itself. So for me, I'm actually the last year of the baby boom, born in 1964, and early on, I think my interest in weather came about through just being really kind of scared of thunderstorms. So it's like, well, if I want to know when I need to hide, maybe I should learn about predicting the weather. What we see over here, this is actually a slide or a picture from the splashdown of Apollo 11 in 1969. And this was not the inspiration. It was actually probably an earlier Apollo mission, but I remember watching it on TV, and it was really, really windy at the splashdown site. And so I took out my crayons and I wrote a weather forecast. And it was today, tornado. Tonight and tomorrow, tornado. And I can't really say that my forecasting accuracy has improved at all since then, if you just take a look at the Weather Challenge standings. But, you know, I was very interested in taking a look at the weather, and hey, we all kind of visualize weather. We're visualizing it with our own eyes, and for a long time we're now using advanced tools such as what Unidata develops to help us analyze and visualize weather and geoscience phenomenon. So that's going to be the subject of the talk, a little bit of an outline. We're going to step in the Wayback Machine and take a look at early attempts of visualization, kind of ending up in the 1970s. We'll show some current examples, actually, and I'll say current in the modern era, dating from maybe the early to mid 1970s. And then we'll take a look at how we are typically visualizing meteorological phenomenons in applications both Unidata and non-Unidata. And then moving on towards, I think, the more interesting and more visionary part of the talk, I want to talk a little bit about browser-based visualization, because I really think that's where a lot of energy is starting to go. And I'll be focusing at the end of the talk with just a little bit of an interesting product that one of our grad students at Albany has spent a lot of time working on as he's completing his PhD dissertation. So, fasten your seatbelts and head back to the 19th century. Obviously, one of the best ways to visualize what's going on in the weather is to just put it on a map. And I believe this may have been the first weather map that was put out by a U.S. agency. The date is January 1st, 1871. So probably a little bit too early for most folks here, I would think. So not a bad. It's kind of funny. Surface-based point data has always been, I think, a harder nut to crack, but this was really one of the first visualizations of weather phenomena, at least in the United States. Move on to, of course, the upper air. It wasn't until the early part of the last century, where folks like Bjerknes realized that in order to really understand what's going on in the atmosphere and be able to predict phenomenon, you can't just look at what's going on at the surface. You need to look in 3 dimensions. And eventually, with the development of ArrayOp network, certainly upper air maps existed before this particular public product that the U.S. Weather Bureau began disseminating in 1948 as part of their daily weather map series, but this was the first one on the 1st of July 1948, and at this point it was a 700 millibar map, and that was the standard in the U.S. weather map daily weather map series for, I think, a few decades before they moved on to the 500 millibar level. A lot of activity in the post-World War II era. The ENIAC computer was rolled out shortly after World War II, and this was the first output. And I believe this may have been a reforecast, because at least from the sources I was looking at, this effort took place on the ENIAC in 1950, but this is a forecast series of maps from January 5th, 1949. So, squint a little bit, and maybe it doesn't look too much different than some of the gridded products you may have worked with back in the day. More to meteorological visualization than just surface obs and gridded data output. Remotely sensed data is part and parcel of what we do. We just heard a couple of interesting talks about the GO-16. Well, the first television picture from space, the Tyle satellite from April 1st, 1960. And, well, I don't know, maybe there was a little bit of a no-port compression that didn't need to be going on back then. But, hey, it was a start, and it was a very exciting start. In addition to satellite data, there's radar data, the WSR-57. I remember seeing my first WSR-57 imagery when I visited the National Weather Service in Rochester as a 13-year-old in 1977. They still had the WSR-57 at the office. This was deployed in 1959. The first surveillance, weather surveillance radar, version 1957. That's where you get the WSR 57 acronym. This was commissioned at the Miami Weather Office following some devastating hurricanes earlier in the 1950s. And this is imagery from Hurricane Donna back now almost 60 years ago. All right, we'll wrap up our trip in the Wayback Machine. I'm not positive where this comes from, but I found it in my archives in my office, and I believe it comes from none other than the synoptic map and punning god, Lance Bosart. All the punnings that I ever did was simply so I could get through the program with Lance. But this is what I believe is a synoptic lab assignment from May 1975, and this is how you did animations back then. If you want to take a look, maybe a bit hard to see for folks back in the room, but here's some nice detailed instructions. You were actually overlaying some gridded fields, some hand-gridded fields, but then matching it up with a series of satellite images, which we actually got from the printed version of the ADDE server, which I don't think really existed. But here's the fanning motion. So I'm not sure if you're going to be a big fan of this, but let's see how well it plays on camera, which will not be very good. I mean, I would totally have failed this, but yeah, see that movement. I think what I'm going to do, I'm going to go back into the archive, and we'll put together a 2017 version of the animation. Then I'll hand it in to Lance and see what he does for me. Okay, let's go into where the stuff that we love, computers, starts to come in. And I think any bit of meteorological visualization has to start with Mercatus. And here's a picture of one of the early deployments of Mercatus, probably at SSCC. Dave, do you recognize this person?
Yeah, he retired about 15 years ago.
Okay.
J.T. Young.
Okay. Yeah, I remember the name. And here's some imagery from Mercatus X version 2003, and I'm pleasantly surprised to hear that there's going to be yet another Mercatus X version coming out to support GOES R, as we just heard in Victor's talk, and then Mercatus V, which is using the same software that powers IDV, also continues to be a partnership going on with SSCC and Unidata. How many folks remember WXP? Woohoo! This was developed, I believe, by a past DeSouza Award winner, Dan Vitor, who's now at the Aviation Weather Center in Kansas City. He worked for Unisys, and I believe when we got our first Unix workstations at Albany in the early to mid-1990s, WXP was installed and ran on our old Sun Solaris.
He developed this at Purdue.
Oh, at Purdue.
Yes.
Okay.
And he took it with him because he was the sole developer supporter of this software, and he brought it to Unisys.
Okay. Well, if you can see the timestamp here, it's still running. Unisys still produces weather products, and this is actually just from a few days ago. So WXP still works. Oh, great! Wow, awesome. Does it run on Linux?
Yeah.
Wow. Oh, all right. I'm going to have to get some more work for me to do when I get back. We also have Grads. Grads also has a long history. And how many people here use Grads? Quite a bit. I was never a big fan of Grads back in the day. I thought the graphics were not, I guess, all right, I'll call them hideous back in the day. But they had, at some point, started using the Cairo visualization package, same visualization that underlies NCL and NCAR Graphics now, and their graphics now look really, really good. And unlike say GEMPAK, which I'll talk about in a minute, Grads does speak OpenDAP, so one can use Grads and communicate kind of the modern way where you can connect to a remote server and display data. when I started doing my first bit of research as a grad student, this was in 1991, I was like, well, you're going to use NCAR Graphics. And at that time, NCAR Graphics was a series of Fortran subroutines, and really at its core right now, NCL is a scripting language that runs on top of NCAR Graphics. So here is a globe view of probably 500 millibar heights here. Still one of the examples that you can download. You can still run it and compile it. But we can move on to, once again, a more pretty visualization system that has its own scripting language, NCL, which is really stands for just NCAR Graphics Command Language. Very widely used. How many people use NCL in their department? Another great advantage of NCL is, first of all, it's very scriptable, and it also really nicely does, it speaks OpenDAP well, and in contrast to grads, yes, has OpenDAP, but NCL has a really mature set of diagnostics. So part and parcel of visualization is that you want to do some analysis behind the scenes to really kind of add some value to products that might be coming in native from the grids, but let's say you want to calculate a more advanced diagnostic on gridded data. So NCL certainly provides that and is still a very major part of our work at UAlbany and more widely in the meteorological community. All right, got to stop and talk about my friend GEMPAK. GEMPAK really was the gateway drug for me. And it really started with a bit of a horror story because actually Scott Jacobs, yet another DeSouza Award recipient, he was finishing his grad degree at Albany just when I started. And I was already a bit of a geek and wanted to log in remotely on my really fast 2400 baud modem. So Scott said, well, just run GEMPAK. There's actually a device driver that'll work on I think I had a Mac SE at that time. And so I logged in and started playing around, and I saw all of these Hurricane Bob data sets in there, and I was like, oh my god, I am completely screwing up John Molinari, professor in our department, just tropical I'm ruining his data, and I quickly logged out. I turned off the modem. But GEMPAK really was where I spent a lot of my time in terms of research. All of my research, after a couple initial attempts with NCAR Graphics, quickly moved over to GEMPAK and started, actually my first job after I got my master's in 1995 was working with Scott Jacobs and Mary Desjardins, yet another DeSouza Award recipient, in developing new subroutines in GEMPAK, and also their interactive GUI interfaces to GEMPAK, which was what formed what we still use today, NAWIPs, National Centers AWIPs. What some folks may not be aware of is when I got my job, the position was with the NSA, or the NMC Transition Project. And this was as AWIPS was being rolled out to the universities, to the Weather Service and to the national centers. The national centers felt that AWIPS did not meet their needs, and so the decision was made to have a version of AWIPS that was completely separate to AWIPS version 1, and it was called National Centers, or NAWIPS, and it was based on GEMPAK. And even today, with the second release of AWIPS, GEMPAK still forms the backbone in terms of the diagnostics that are really what we thrive on, especially in the university research community, but also at operational centers. I did have some imagery for WSR 57, so here's the 88D. This is one of the first images that got transmitted. It wasn't quite operational yet, but this was at the Norman, Oklahoma, or Oklahoma City site, KTLX, from June of 1991. And this very data set I pulled from the AWS hosted thread server just the other day, and that's why I was bugging Ryan a little while ago when it wasn't answering my request from the thread server. So I got it another way, but we won't tell. Okay, so visualization. All of these initial products were running programs, and typically on the command line. I love the command line. You have a lot of power with the command line, but when it comes to ease of obtaining products, you really need to put work into your graphical user interface. So as I said, with NAWIPs, in addition to GEMPAK, it was decided you really needed to build a graphical front end to GEMPAK, and that's where the N programs started. And the very first one that folks may remember, how many people ever used NTRANS? Okay, wow, that's great. NTRANS was the first interface where you could take products that you developed using GEMPAK. So in this case, this probably was running GDplot here, and put together a loop of 500 millibar heights from the NAM model. And with the X11 motif software library, you could step backwards, forwards, put together 4-panel plots. When I worked at NSHARP from 95 to 97, I was a regular attendee at the daily weather forecast briefings, and it was basically all done using NTRANS. NTRANS did not have the interactivity that was needed, and that's where NMAP came about, and it's more familiar to many folks as NMAP 2. And still is used. How many people still use it in their weather labs? We got maybe a half. Bill's kind of on the fence. I think we stopped ours about No, we still have a few. We still have a few in our labs. So we'll say 1.5. So as you can see, in contrast to NTRANS, you've got certainly a lot more buttons here. You had zooming capability. And what you also were able to do, and this was something that was an operational requirement, back in the day when products needed to be generated, NSHARP had this old system that was called Intergraph. And that was what was used to develop and put out, say, the analyses that would be distributed, say, via fax. A lot of folks certainly had map rooms that got fax products. Still a few get generated even at this day. So NMAP, if you take a look at this icon here with the little detached low and a cold front here, the product generation was built into NMAP, and it was called PGen, product generation. So I always have fun showing this to our students. So rolled my little map here. You can note the cold air jamming. I mean, this is not a real map, but lots of fun. There's a snowstorm that never always seems to miss Albany, but not in this map. But I believe still to this day, as we wait for the National Center's perspective to be finalized with the current version of AWIPS, NMAP 2 is still being used for product generation at the National Centers. And NSHARP, and this was actually a project that I worked on quite a bit in my last year as a developer for NSEP. NSHARP is their port of SHARP, which was the sounding and hodograph analysis program that was developed, I believe, by John Hart. I'm not sure if it's the same John Hart that's at SPC now. Oh, he is. Okay. So actually, what I was involved in was taking a lot of these routines that ran on a PC. This was a PC-based program, SHARP, and kind of recoding the algorithms and bringing them into the GEMPAK and AWIPS sphere of influence. And although it's not interactive on this PowerPoint slide, one of the great things about SHARP is that it allowed a forecaster or a student or a researcher to manipulate the sounding to see how things may evolve during the course of the day. Of course, a 12Z sounding is morning for most places in the continental U.S., so one of the things you might want to do is kind of warm up the lower levels and see how some of the convective parameters may change. Of course, this is Albany, so the Cape is 0. All right, we move on, and I showed that upper air map a little while ago. When you are trying to explain atmospheric structure to students, a plan view map can only go so far. You really need to leverage the power of three-dimensional visualization to try to get the point across to the students. So Viz 5D came about in the 1990s. Bill Hibbard at SSCC developed the Viz 5D program and graphic libraries to support it, the Viz AD library. And realizing that this is still a two-dimensional canvas that we have here, but the way our eyes work, we can certainly see a three-dimensional structure here. So Viz 5D was put together and was an early and I think quite popular attempt, and is still used in some departments to this day to visualize model output using 3 dimensions. But a lot of the underlying library that powered Viz 5D really inspired the development of the integrated data viewer, which of course Unidata has been involved in for probably about 20 years now. Yep, I think when I first started working back at Albany in 2001, there was probably version 2 of IDV that was developed. And let's just see if we can get the animation to fire on this. So this is just forecast gridded output. There we go. So just a little bit of an animation of a past case, and a little hard to see here, but you're actually seeing trajectories, forecast trajectories, which is a recent addition to IDV. And this is one of the examples that's gone into the lab manual that myself, Brian Mapes, and Gary Lackmann have finally published by AMS Press that uses the IDV to complement Gary's very successful synoptic textbook that came out also by AMS Press a few years ago. And, I'm sure I haven't mentioned all of the various programs that are out there. Of course, there still are commercial programs. MATLAB still used quite a bit. IDL perhaps less so these days. One program that's also developed right here at NCAR is Vapor, a program that I have not really had the chance to play with much, but I think has a lot of very interesting features, especially for viewing real high resolution processes. And then, of course, I'd be remiss in not talking about all the great work that Michael James has been doing using AWEPS. So how do we typically visualize and put together products on the website? Still to this day, I think things are starting to change, but what we typically do, we run our visualization and analysis package of choice, generate graphics, GIFs, PNGs, JPEGs, whatever. We plop them on a web server, and we visualize them. So, for example, I'll show you some static images, and I'll show you some example websites that we have at UAlbany that kind of show how most visualization on the web is still done. So here's a one frame of an animation from WARF output using GEMPAK. A similar graphic using NCL, and then we have some Python-derived products that have been put together by our own newly minted user.com student representative, Tomer Berg. And Tomer's kind of an interesting, it's interesting how he's evolved, because when he started his real-time product generation, it was using GEMPAK, and probably, what you'd say in the last, how long ago did you switch to Python?
Probably about a year ago.
Okay, yep. And the results have been great. And then, of course, we have some great work that's going on with Ryan and company using MetPy. And I think one of the things here that we're finally going to see, one of the reasons I've been really reluctant to move away from GEMPAK is because it's so good with point observations and visualizing them. Surface weather map and a SKU-T. So I think MetPy is going to really provide finally a viable alternative for product generation of synaptic point maps and upper air maps and soundings. So before I move on to interactivity in the browser, let us take a look at how some of these products actually get visualized on the web. So I showed my example for GEMPAK, and so oops, sorry about that. Let's get the maximize button here. So here is a web page that we have for our real-time wharf simulations that we run at U Albany. And so how do we do it? Well, these are all GEMPAK maps we've got a bunch of GIFs that are created, and we can just kind of nicely loop through them. So somewhat interactive, wouldn't you say? Got a bunch of different products here. I'll provide a list of all the various URLs that I've used in this talk to interested parties afterwards. Similarly, the second map that I showed was used using NCL. Alicia Bentley's really popular suite of products that she uses, and try to step through here, but we can kind of show what happens. We have an analysis product here, and I may not wait for the full time to have all of the various forecast hours and also past analyses. This is kind of a nice product because we can look at the past as well as what the models are predicting in the future. I might just jump to one just to show a little bit of interactivity here. And then finally, I will show off Tomer's maps. He's put together some really great stuff. And so here we have some real-time model guidance, and we also have the RTMA. And we go here. Again, I won't step through these. I encourage folks to take a look after the talk is over, when you'll have the full URLs and kind of play with it. But the moral of the story is we've got interactivity here in the browser, but the way that we are realizing it is that we're using graphics that have been pre-generated and are stored and then accessible through kind of a nice web interface. You can also do similar stuff using Python. In the class that I co-teach with Ross Lazier, it's an Introduction to Data Analysis and Visualization for our junior level atmospheric science students. This past spring semester, it's taught every spring, we had our first bit of Python introduced into the curriculum. Cut out a little bit of the GEMPAK and the NMAP stuff. And so one of the things that I had folks use is put together some Jupyter notebooks and pick a case. So the two things that I had them do as part of their final presentation was, first of all, put together either a continental or, in this case, a global view of the 500 millibar pattern derived from the CFSR. And this was from our CFSR archive that we have running on an OpenDAP server at U Albany. And then the other thing that we did was I gratefully accepted the great notebook that Ryan put together for accessing Nextred Level 2 from the AWS server. And this is where I was very frequently bugging Ryan when project time was coming, because we found that when all the students were hitting the thread server on AWS, kind of said, enough's enough, I'm going home for a little bit. So and Ryan, to his credit, he would respond even at 9 o'clock p.m. on a Sunday night. Thank you so much for that, Ryan. But here we have a radar image animation from the snowstorm that the Northeast experienced in the middle of March this past year. One of the great things about this is that once you have the notebook, the graphics there, it's just waiting for you to reload it. And one of the things I stress to the students is like, have this already. You won't have to do a thing when you're up there. All you got to do is open up your web page, and there it is. So I think that worked really, really nicely. So let's step back to the dreaded PowerPoint, and we'll pick up with browser-based visualization. All right. This is kind of an interesting way of using some interactivity within the Jupyter Notebook, and this is a product that is developed by the same folks that put together Anaconda. It's called GeoViews. Anyone here using GeoViews at all? Great. I've just kind of done the very, very basic. I'll show a little bit of a demo when I step out of this block in a minute, but I think it certainly holds some promise. All right, now we get to stuff that I think is really started to excite people and has really excited me about browser-based visualization. So a couple years ago, this kind of went semi-viral, was this wind-based visualization. And I think the first one that I found was from this site called hint.wind.fm. And this obviously will look a lot better once I go back to the browser to show it to you. And so some folks took the hint and put together the even more famous earth.nullschool.net. This was actually developed by a guy who's got a GitHub site, and he's not even a meteorologist. He just put it together because it was cool. And man, is it ever cool. And the code is right there on GitHub for you. And we'll take a further look at that in just a little bit. So other entities have kind of picked up on this hint.wind.fm model. This is Ventisky. Once again, show of hands. How many people have seen Ventisky? Maybe a little bit less. But what's really kind of neat about this, there's more layers that can be put on. So what we see here are the wind fields. And okay, yeah, that's a bug, maybe a little bug in the code there. But you can overlay fields from various models. So really kind of exciting stuff there. And that's not the only way one can do visualization. Web map service, serving up images in a tiled format is, I think, really cool. And here we start, and not that this is not being done in the various like Earth Nullschool family of products that I just showed you. Really, it uses a language that we haven't talked about too much, but I think is really starting to become extremely relevant in our field, and that's JavaScript. And one of the best mapping libraries that we've got is an open source product called Leaflet. So how many folks have been doing any kind of rendering using Leaflet? All right, still a few people. That's good. So it turns out that Threads actually has WMS support, courtesy of the folks in Reading that put together the NCWMS web map service that can serve out grids using the NetCDF Java backend library. It takes your grid of data, converts it to NetCDF, and then you can visualize it, and it's served out using WMS. And then you can use a tool like you can code using JavaScript Leaflet and put together some nice interactive maps. So this is some of my baby steps into it, and this is actually one frame from the high-resolution rapid refresh of forecast radar reflectivity. And of course, as you'll see in the demonstration, when you put something like this together, it has to be about the driest time in the CONUS in like the last 100 years. But fortunately, there was a little bit of precipitation going off the southeast coast. You'll see even less precip in the map that I'll show you in a little bit. So that's really kind of cool stuff. And as you'll see in the demo, the interactivity is really key. So what I have noticed is that with Wind.fm and Earth Nullschool and Ventisky, they're doing great stuff. They're taking products that are that come right in through in GRIB format. They're converting it to JSON and visualizing it, and it's kind of stuff that most folks might have some familiarity with, so sea level pressure, and maybe for more advanced folks, yeah, there's a 500 millibar map or temperature. But here's where I see the way that we can really start using all the knowledge that we have and start using these open source technologies and visualizing stuff that's more interesting and more novel to us in our community. Once again, I'll demo this, but what we are showing here is not surface winds, but actually winds on the 2 PVU surface. In other words, the dynamic tropopause. Okay, so once again, we'll take a little break from the presentation and go to some more websites. Okay. All right. Maximize button. So, here's a link to GeoViews for those of you who might want to look a little bit more. Just Google GeoViews, you'll come up with the usual Python-based documentation. To kind of show the interactivity that I showed for GeoViews. What we've got here is GFS from a couple days ago, and the interactivity comes here is that we've got these sliding widgets where I can go away. I don't know why this always happens, but step forward. I think when you click on the screen, it makes the dictionary come up. All right. So here's some animation here going forward in time. So I've got all the times in the forecast, and I have a few levels. So I've got 500, I've got 700, I've got 850. And I don't have good contour labels. This is kind of just what GeoViews comes up with. Need to spend a little bit more time in customizing the contour levels. But nevertheless, it's kind of cool to see some interactivity that's provided to you in the Jupyter browser. All right, here's a wind map in action. So in this case, pretty basic. It's just the surface winds. And here's Nullschool in all its glory. Click on here, and you can bring up several more options where you can choose from different models, you can choose from different fields. Again, that interactivity is provided to you, and all you need to do is fire up your web browser of your choice, as long as it probably isn't Internet Explorer. And here's Ventisky. I can play around a little bit. Maybe we'll try overlaying clouds. Takes a little bit of time to resolve, but yep, there it is. And let's also mention, I almost forgot to put this in, but once Real Earth was mentioned in the recent discussions just prior to this presentation. Looks like the animation may not be working right here, but same kind of idea, fully browser-based. Here's a great way for folks to access worldwide satellite imagery, and you can choose from a bunch of different satellite products, including GOES-R, to put together your your worldwide mosaic. What also is provided to you is that you can change the background base map, for example. So once again, we're seeing this pattern where we are moving towards all of the interactivity we're now doing using the browser. So a little bit on NCWMS. I have an NCWMS server running on one of my systems. And what this can provide to you is, for example, every hour I am pulling in the HER. And here's where GEMPAK still remains relevant, because as I said, one of the interesting things is we can visualize things that are not just provided to you in the grid fields. So what I'm doing, at least for now, because it works and it's reasonably fast, I'm actually using GEMPAK and using GD-Diag to create various diagnostic products that I can display and serve out using a web map server. Most of the products that I have here are still just from the grid itself, but I just started playing around with frontogenesis. Doesn't look too great just yet. Need to work on the exact scaling, but put that together, and in this case, I've got my really quiet map of reflectivity, but I can pan around, I can zoom in, and fully interact with this map. And I think this is the way that most people now, maybe outside of our community, are getting and visualizing data. It's all browser-based. And what I've got here finally is our Nullschool that all I did was pop in the DT, winds on the dynamic tropopause. Notice that since it's the 2 PVU service, what we're not seeing is anything in the southern hemisphere. But look how easy moving things around are. If I had my mouse, I could do this even faster. But the interactivity is really well apparent. So playing around a lot, and it actually forms the basis of the last major part of my talk. So we'll step back to the presentation. So one of our grad students, as part of his PhD research, I mean, he's actually an MJO guy, studies with Paul Roundy, but he's really interested in data and visualization. His name is Larry Gleckler. And what he has done is, in partnership with a group in our geography and planning department that does a lot of visualization that's JavaScript-based, is that he's put together an interactive tool to browse and display fields from the CFSR, and we're talking about the 1979 to 2010 classic CFSR. And 3 components to this. There's WebGL, there's React, which is a JavaScript interactivity library that's used by Facebook, and something that we tend not to use much in our field, and that is databases. So one of the cool things that Larry has done is that he has leveraged a Postgres database and has populated it with geopotential height, winds, temperatures, and anomalies, and using a Postgres database and indexing it, and you will see that the responsiveness in the browser to this is really great. So let's take a look at how that works on screen. And this is the website for the partner organization, Albany Visualization and Informatics Labs. Once again, that is part of the Geography and Planning Department. So let's see if this is still going to respond. So what we've got here, we've got a map, we've got interactivity, and what we are showing here is 500 millibar heights from the CFSR. You can spin things around, etc. Same kind of interactivity that we saw using the Nullschool. And you can change the date, and notice how very amazingly quick we get results. It's not just geopotential height that we can display. We can actually do anomalies from the 1979 to 2010 CLIMO, and pick your favorite case. I'm not going to stress it too far because it didn't show on the screen, but this is Larry has dubbed this version 0.01. So he said if you do too many things with it, it will crash. But nevertheless, this is, I think, a really cool and exciting tool moving forward. So just about set. One other bit of visualization I want to talk about is using GPUs. And for those of you who haven't seen Lee Orff's amazing ultra high resolution visualization of a tornadic thunderstorm, all you have to do is go to orff.media and you will see that. Okay, running short in time, so let's get out of the browser and we'll wrap things up. So, what do? We forecast. We forecast the future. So let's do some forecasting of visualization. So one of the things that we've talked about for years, for those of you who might know Jim Steenberg at Utah, whenever we do blue sky, back when I first joined UserCom, it was like, I just want something that's like in Star Trek. Give me the 500 millibar map. Okay? So here's where I think some opportunities are. Seriously, with things like Alexa and with Siri. Serious here. I'm not going to, in the interest of time, not going to repeat this and interact with Siri on my MacBook. But here's a question. Tell me about the blizzard of 1993. No problem. Came up with a nice link. So my next question. Give me a weather map for the blizzard of 1993. I think, this was pie in the sky a few years ago, but I think within 5 years, this will work. And I think it may be folks like us and folks like Unidata who make this possible. And as I just mentioned, in terms of visualization, with all that, you can't talk about good visualization without talking about CUDA and GPU-based computing. So let's wrap things up. And I actually have a fairly impressive set of acknowledgments, because this is all about thanking the community and thanking folks that got me to where I am today. So bear with me. But I want to start with my advisors as a master's student. Now I kind of advise them on computer matters. But my background, even though I loved weather, I was actually a pre-med in undergraduate, and then I was switched to cognitive psychology. But finally, that was just not enough. And Lance and Dan, even though I had maybe 2 classes in meteorology that I took outside of my main program, had confidence in me and took me on as a master's student. Gary Lackmann, many folks know very well, very much involved in the Unidata community. He was kind of my go-to guy in terms of doing all sorts of cool stuff with GEMPAK visualization. He taught me how to, for example, do Q vectors before that was available in GDDiag. Scott Jacobs, of course, he showed me GEMPAK as a grad student in 1991, and he kind of got me even further along when I worked with him at NSHARP in the mid to late 1990s. And I think one of the reasons I got my job, here's yet another DeSouza Award recipient, Dave Knight from U Albany, besides his great work in helping the community receive NLDN for all these years. I think one of the things that might have put me over the top when I was applying for my job in 1995 is that I wanted to tweak the GD Cross program so it would actually show fields underground. And it was working with Dave that we were actually able to do it just by modifying the code. And when I was applying for the job, Dave was one of my references. And I think the fact that I'd actually tinkered around with the code with Dave's help certainly, I think, helped get me my job. My first kind of interaction with the Unidata community was probably joining the GEMBUD mailing list. And, of course, Steve Chiswell was the man here at Unidata who took care of all sorts of GEMPAK-related questions. So thank you to Steve. Probably what really turned my career around was in 2008 when I went to an IDV workshop that Brendan Hoke sponsored at Plymouth State University. And it was with IDV, so we have you on, and then Don Murray and Jeff McWhirter, who were with the IDV developers along with UN at that time. And after that meeting, at some point during the meeting, Don said, you ought to consider joining UserCom. And so I did, and another year later, I joined. And I cannot tell you how that's changed my career. Instead of just kind of fixing your software and unjamming your printer, it just really kind of reoriented my career. It's been great to get back into kind of the academic and research community. Never went to AMS conferences and other conferences until after a year or two under my belt, picking up some of the cool stuff that folks here at Unidata have done. And that really was the gateway in 2008. I want to thank Larry and the group of Avail. One of the most rewarding things is teaching undergraduates, which is something I started also in 2008. And Larry was one of my students, Tumwer was one of my students, and there's nothing more satisfying to me, and I'm sure it's the same for all of you who teach, is to see your students kind of flourish and do things that completely blow you away. So thanks to Larry and the Avail group. My co-instructor in 350, we took the kind of bold step forward into Python. We both loved GEMPAK, and it was kind of sad to go away from it. But I think we made it really work well, and we're looking forward to further increasing the time in our 350 class, talking more about it. Thanks also to Mohan. And actually, Mohan, I know I've talked to you about this before, but our interaction goes way back, probably about the time when you had joined Unidata, but in 1990, when I was applying to grad school, I actually got a call from Mohan, who was looking for grad students at the time. And sorry I didn't accept, but maybe in the back of my mind, I knew ultimately we'd be working together. Thank you also to Tom, who's been such a great help, and also in my 350 class, Tom, with all his knowledge with Mercatus and the ADDE, was so helpful in getting an easy way for our students to download and visualize archived satellite data, so you don't have to do the little fanning thing from the 1970s. And a couple other past recipients of the DeSouza Award, Gilbert Sebenst, who I got to know virtually with all these LDM questions back in the 1990s, and Daryl Hersman, also, who I've seen many times on the email list. First time I got to meet him in person was in 2012 at the Triennial Workshop, and that was the first time I ever saw what was then called the IPython notebook, and kind of blew me away. So thank you, Daryl, for introducing me to that. And finally, let's acknowledge the Russell DeSouza himself, the true spirit of community service that all of the recipients of this award, in his honor, as Mohan eloquently said, he kind of exemplifies what Unidata has brought to us and to the community. So just about set. One final thing is, don't forget to run GPEND. Thank you very much. And
unless you have an _GF program, then you don't need to run it.
That is very true. But it never hurts. It never hurts to run GPEND. In some of my scripts, I had probably 3 GPENDs just to make sure. So happy to entertain any questions. And time outside the meeting, I'd be happy to show a little bit more of some of the interactive tools, especially the Weather Atlas. Yep, Russ?
So how well is any of this stuff going to work as people move more towards phones and tablets as their primary way to look at stuff?
Well, actually, the Avail folks who have been working with the Weather Atlas, that was one of the first questions that I asked them, and they said JSON and JavaScript is the way to go, and if you go to, I believe if you go to Nullschool, actually I don't know how well it works in the browser. I did try my Her leaflet on my iPhone, and sad to say, it did crash every browser. So there's still some, and there's a GitHub unresolved issue raised to that. So I'm not quite, they're blaming it on the browser implementation. But sure, any folks use Dark Sky? Yep. So very interactive. It's actually developed by folks across the river in Troy, New York, former RPI students. And similar to the Earth Nullschool guy, Cameron Beccario, these folks who who develop dark sky are not meteorologists. So I think there's a lot we could learn from them, and there's a lot they could learn from us.
I don't know if it's still true, but when Nullschool was unveiled, it actually used to fetch data from the Unidata threads.
Oh, I think so. If you go into the code, you will see it. Yeah. Anyone else? Yes.
How do you think we're going to divorce ourselves from the reliance on CPUs, particularly as you've shown for the auth visualizations, but in general, GPU computing being a little bit more efficient for dealing with a lot of the things we work with? So, how do you think that divorce is going to go?
I can only speculate. I think it's going to be slow, maybe not horribly messy, but it's. I think last year I went to supercomputing in Salt Lake City, and Brian Etherton gave a presentation about modeling using GPU. We're very slowly going in that direction. I mean, I think I'm really excited by the stuff that we can do in terms of visualization, though. I mean, I can almost envision a time where we're running a high-resolution model in real time, and we can actually, as Lee Orff's demo has shown, actually maybe see the convective storms unfold in almost quasi-real time. Don't have the experience or knowledge really to speculate any more than that, but it's clearly getting there. I think one of the big issues still is porting code so it runs efficiently on GPUs. Yep, Rich.
I remember right in the beginning of the NetCDF user's manual, it says something like, NetCDF is not a database, or something like that. and it explains why it was created that way and for efficient access to the data. So you're going back to a database here.
Mm-hmm.
Is that? Did you try file-based and it was just not fast enough?
Yes. The initial work that Larry did with the Veil was using GRIBs, kind of using the same way that Earth Nullschool worked with it. And the developer at the Avail group was like, well, let's try a different way. Now, one of the penalties that you're going to pay is the disk space is much. You pay much more in terms of the amount of disk space you have to devote to the database, and then you're also converting it to JSON format, which is it's human readable. But it's big, and one of the things I didn't show is that this is CFSR global data, but it's 2.5 degree. Once you start going to 1 degree, quarter degree, but on the other hand, we know that disk space continues to advance, and once we have 1 petabyte solid-state disks in all of our machines or up in the cloud, I think it will become pretty viable, and I think it's going to offer this speed of visualization and searching. I mean, databases are used just about everywhere, but not so much in our field. And I think we're at that point where it's going to become an increasingly attractive option, especially as the data sets get higher and higher resolution.
It could be another way of delivering binary data to the browser.
Mm-hmm. Yeah, I looked a little bit about compressed JSON, and I saw a few interesting blog posts about no, you'd never want to do that. But but it seems like folks are thinking about that.
There's there's protobot, right, and that's already in the. I don't know. It seems like there's a lot of interesting things that could be done there.
Mm-hmm. It's always exciting times.
Yeah.
It was 20 years ago, and it still is. All right.
Any other questions? If not, let's thank him again for a fantastic presentation.
Thank you very much.